Today I'm going to show you how to overcome the laser extended space error that you will encounter if you try to laser a picture that may be too large or happens to be in an awkward position. You come across this error when you try to do a bitmap, and you will start engraving and all seem to be working all right, and the information is being transmitted from your computer over to the laser, and then the progress bar may hang around at 80% and keep on moving and moving and moving, but the laser stops. There's no engraving, and you go over to the machine and you have a look, and it's only done a small amount of the image. And you look at your control panel on your laser and you get the lovely laser extended space error. Now, what causes this, according to the wise men of the web, they say that it is that the laser needs a run-up, like a soccer player going to kick the ball off the ground, or an American gridiron guy going for goals. You need a run-up, then you can kick the ball. So what happens is that the laser actually needs a run-up and a run-down to before and after it starts engraving. So if you have it set to the top left corner, there is no run-up area for it. I read the wise men fixes, and the trouble I found that if I shift my picture 20 millimeters away from the top left corner, I still got the same problem, because with Laserworks it attached the origin to the top left corner of the picture. So if I moved the picture 50 millimeters away, the origin moved 50 millimeters away. So one solution I found was then to draw a 5 millimeter rectangle up at the top left corner at origin 0, 0. Then you move your picture 20 millimeters away from the origin, and then you try your cut. And depending on the size of your image, that should work sometimes. What I also found, it depends on the way you are engraving and picture and all those sort of variables. So I then come up with a solution that I use to laser engrave the text for the CNC4A SX3CNC mill, particularly the control panel. I had a lot of buttons and holes and LEDs that I wanted to label, and I thought I would try the laser engraving. I'll just take you now through the steps that I did to laser engrave the fill. To laser fill text, you have to import it as a single PNG for each word from Coreldraw layout. On the control panel, I didn't want vector text because that is either a single line or an outline and an inner line, which I didn't want. I wanted a filled text. So to laser fill text, you have to export it as a single PNG for each word from the Coreldraw layout. Do a test first to find the maximum words or picture size you can laser before getting the extended space hanging problem. So note that down when you've done that test. Now for the filled text, in Coreldraw, set up your Coreldraw layout so that the vectors, lines, circles, etc. start at the top left corner to match the Laserworks 00 origin at the top left corner. Check where your Laserworks origin is and adjust as required. Set up your Coreldraw page size, etc. to match your Laserworks table cut size. I've set my page to be the same size as the cut size of the laser table. If you have no vectors, add a 5 millimeter square in the top left corner of the Coreldraw layout. You can also add a little vector plus to help indicate in Laserworks where the word should go. Add your filled text in their correct location, size, orientation, etc. to the vectors. So mine was next to some holes that were drilled in the tube, so I then aligned the text up to those holes. If you only have the added 5 millimeter square, add your text starting 20 millimeters away from the top left square. So that's 20 plus 20. That's to give you the run up. The text needs to be away from the 5 millimeter square, so Laserworks has enough free room to cut. Select the word and write down its height, width, X and Y dimensions from the Coreldraw layout. When you export the selected word only as a PNG, note the dimensions for the height and width that particular window tells you it's going to be saved as, and add the height, width and the Corel X and Y dimensions to the file name. You can also have a list of the words that you're going to export in Notepad and add it there as well. Repeat for all the words required. So if you have 10 words, you'll have 10 separate PNG files for each word. Then copy your text text layer and paste it down. You will now have a copy of your text layer. Then when that is still selected so that all of the text in that layer is highlighted, on your keyboard press Control Q and that will convert the text to curves. Rename that layer Text Curves. So you have 3 layers, a vector layer, a text layer and a text curves layer. Now export the Coreldraw vectors layers as a DXF. You can hide the original filled text layer, then export the Coreldraw layout vectors and the text curves layer as a DXF. You will use the text curves as an indication of where to place your text on the LaserWorks layout. Now that you've completed the Coreldraw process, you now need to open up LaserWorks and import the base vector DXF file. That is the one that I used to align all the text with. Move it to the 00 origin at the top left corner by clicking the top left icon, 5th from the right. Click the Show Data icon, 12th from the left to fit the screen. Select all the non-text vectors and add them to their own new layer by clicking a color box at the bottom left corner. Change the curves text vector layer output to no, also the first layer if required. You now need to align the control panel tube position on the laser table to match the laser cutting position. You move the tube to suit the LaserWorks position, not the other way around. The corner of the tube needs to match the LaserWorks 00 origin to start with. You can use your eyes or a pointer or whatever method you use to start with. If you made up a set of Laser4A table pin standoffs, you can add a spacer between them for adjustment. So you put in a 20mm spacer, you do your test cut, and if it's 2mm out, you just put a piece of material 2mm thick in there. Select the 2 vectors at the opposite ends of the tube drawing to aid in the positioning of the text to the tube. So that way you only have to worry about aligning the furthermost points, and that's what you use to get it square and perpendicular. Add those 2 vectors to a new layer, change the speed, power and output to engrave thin cardboard. I use a Weet-Bix cereal box and 100mm per second, 15% to engrave and 75mm per second and 30% to cut. We will not be cutting. You can add a thin metal sheet, such as one cut from an aluminium drink can, over the painted test area to protect it from any burn through from the laser. Tape the cardboard to one side of the tube so that you can slide the aluminium sheet in and out to check the hole alignment. You need to move the tube on the laser table to align it to the laser cuts. Test and adjust the tube as many times as is required to get it aligned. Add more vectors to the layer and test their position to check that the text positions will be in the right place. This may take a long time and you may have to try various approaches. When the laser engraving on the cardboard is as close as you can get it to the correct vector positions, then import your first text PNG picture. Note its size and adjust it to match the size that it was PNG saved as. Change its XY location to match the vector curve's text location. Calculate it from the dimensions on its file name. Move all the test vectors back to the main layer. The test layer will then remove itself. Change the text PNG BMP scan layer speed and power settings to engrave the cardboard again. Place a piece of cardboard at the location where the text will be engraved on the tube. Slip a piece of aluminium sheet under it to stop it burning through again. Select the text and click the BMP icon 18th from the left. Change the settings to dither, black and white, and click Apply to View, or use your own tested settings. The click Apply to View does not alter the original file. Laser the cardboard and check the text position, its size, its quality, etc. If correct, then remove the cardboard and laser the engraved text into the paint. Check the quality and adjust the speed and power settings to get the best surface finish for the type of paint. On the tube there was originally powder coating, and I then sprayed it blue using caliper paint. I also do 2 cuts, and I had noticed that the powder coating tended to be slightly smaller than the blue outline, so that gave a light highlight to the text, so I left it at that. I used 80mm per second and 20% power. Change the output to no when that text layer is finished. Import and test the remaining text files one at a time, adjusting each one as required. When you do import the next PNG file, it will add it to the same layer as the original one. So if you forget to delete it, or if you forget to delete the actual picture from Laserworks, it will burn the file again. So if you've got the paint and you've engraved it nicely, you don't want to engrave it a second time. So it is one picture at a time. And this is the final result. And as you can see, it's quite attractive. I hope that helps you overcome the dreaded extended space error. So thanks for watching.